Hello, everyone. Welcome to my channel. This is educational channel, and we focus on the esoteric and obscure and important things that would enrich your life if you knew about them. And this is the 188th video that we've done on the reciprocal system of theory. This was a theory derived by Dewey B. Larson back in the 20th century, and he wrote a lot of books on various topics such as physics, astrophysics, astronomy, chemistry, economics, metaphysics, religion, dream interpretation, other aspects of psychology. Those are all in one book on metaphysics. And his followers have followed up on that, and we will go into some of the works of his followers a little bit later on. But right now we're looking at his 1979 book that's called Nothing But Motion. And indeed, that's the basic idea behind Larson's system, is that we live in a universe of motion. The universe is not made out of matter, like the ancient Greeks thought, and it's not made out of energy, like Ian's thought, but it is made out of motion. Motion, in fact, is matter and energy are, in fact, different kinds of motion. And motion for Larson is the relationship between space and time. Sets up a generalized reciprocal relationship between space and time. And really all fundamental quantities are relationships between space and time and can be expressed exclusively with a fraction, with space or time as the numerator and space, time or space as the denominator. But time or space can come in multi-dimensions. That's what Larson calls coordinate space and coordinate time. We generally recognize the coordinate space part, but not the coordinate time part. And then there is also clock time and clock space. This is a one-dimensional scalar motion, a motion that has a magnitude and no direction, or all directions, no particular direction. And that is the clock. The time is always getting later and later and later and later. So too, space is also getting farther and farther and farther apart, and but in no particular direction. And we generally recognize the clock time part, but not so much the clock space part. Also, there is a discrete unit postulate. That means that time and space come only in chunks, small, very small chunks, but chunks nonetheless. There's no continuity there. There's a minimum unit of time and a minimum unit of space. Larson calls that the unit of time and the unit of space. He actually just derived that here in chapter 13 on physical constants, that the natural unit of time is 1.52 times 10 to the minus 16 seconds. And the natural unit of space is 4.56 times 10 to the minus 6 centimeters. And when you take 1 unit of space in 1 unit of time, you have the speed of light, which is basically 3 times 10 to the 10 centimeters. And so that's so basically the speed of light is the midpoint of the universe, or the null point, the origin, the ether, the what Larson calls the natural reference system is the motion, the progression of space-time. Einstein thought that the speed of light was the maximum speed of the universe because he only knew about the material sector, the half of the universe that is moving slower than the speed of light. But it turns out that there's actually half of the universe that's also moving faster than the speed of light, which Larson calls the cosmic sector, and which we don't know anything about, basically. And that's where there is coordinate time, three-dimensional time, and clock space, one-dimensional progressing space. Now, we don't know anything really about this cosmic sector except that we can extrapolate from the material sector. So we know what's going on in the material sector from the scientists' observations and measurements. And all we have to do then to understand what's going on in the cosmic sector is to extrapolate by inverting the roles of space and time. So where what's going on in the material sector is a relationship between time and space, over here in the cosmic sector, that exact same relationship exists, but it is between space and time, or however I phrased it, the opposite. You invert in order to arrive at what's going on in the material, in the cosmic sector. The cosmic sector has to do with more with life phenomena, consciousness phenomena, intelligence phenomena, and probably a lot of other things too, that some of Larson's followers have delved into a lot more deeply, and we will cover those things. Okay, we're going to take over here in the middle of this chapter on the basic physical constants. He just got done deriving the natural unit of time. It's the reciprocal of the Rydberg frequency, 1.52 times 10 to the minus 16 seconds. Multiplying the unit of time by the natural unit of speed, we obtain the value of the natural unit of space, 4.56 times 10 to the minus 6 centimeters. By combining these two natural units as required, the natural units of all of the quantities of the velocity group can be calculated. Those of the inverse quantities, the energy group, can also be calculated in the same centimeter second terms, but this gives us expressions such as 3.711381 times 10 to the minus 32 seconds to the third power over centimeters to the third power, which is the natural unit of mass. Okay, mass in Larson's system is time to the third power over space to the third power. So he just plugs in the natural unit of time into that and then takes it to the third power and puts it over the natural unit of space that he also takes to the third power. And so the natural unit of mass is actually 3.7 times 10 to the minus 32nd seconds to the third power over centimeters to the third power. This value has no practical use because the inverse relations between the quantities of the velocity group and those of the energy group have not hitherto been recognized. In setting up the conventional system of units, it has been assumed that mass is another fundamental quantity for which an additional arbitrary unit is necessary. The ratio of the velocity-based unit of mass to this arbitrary unit, the gram, can be derived from any clearly defined physical relation involving mass that has been accurately measured in conventional units. As indicated earlier, the measurement selected for this purpose is that of Avogadro's constant. This constant is the number of molecules per gram molecular weight, or in application to atoms, the number of atoms per gram atomic weight. The reported value is 6.02 times 10 to the 23rd. This is the Avogadro's constant. The reciprocal of this number, 1.66 times 10 to the minus 24th in grams, is therefore the mass equivalent of a unit atomic weight, the unit of inertial mass, as we will call it. And now, again, Larson uses this concept of equivalent space. In this case, he's using equivalent atomic weight. The equivalent space is if there is a motion in time, we do not see time, we see space. We make our observations in space. And so if there is a phenomenon that is occurring in time, we see it as the inverse action in space. So, for example, his example of a white dwarf star is if you have a star that is exploding, a normal supernova, the star that's exploding, it generally explodes in space, and we see it as an exploding star. But if the explosion is particularly powerful and it exceeds the speed of light, then the explosion actually is occurring in time, not in space, because the coordinate time, three-dimensional time, is a property of faster than light movement. So if it's exploding faster than the speed of light, then the explosion is actually occurring in time. It's an explosion in time. We don't see time, however. We see space. And so we see that exploding star in time as an imploding star in space. So that's what he calls equivalent space. The event is actually occurring in time, but since we don't see time, we see the inverse of the action in space. And I believe that's what he's talking about here with the unit of inertial mass. We don't see mass, but we see its equivalent of unit atomic weight. Therefore, the mass equivalent of unit atomic weight, the unit of inertial mass, as we will call it. With the addition of the value of the natural unit of inertial mass to the values previously derived for the natural units of space and time, we now have all the information required for calculation of the natural units of the other primary quantities of the mechanical system. The mechanical units can be summarized as follows. Space, 4.56 times 10 to the minus 6 centimeters. Time, 1.52 times 10 to the minus 16 seconds. Speed, 2.998 times 10 to the 10 centimeters per second. Acceleration, 1.97 times 10 to the 26th centimeters per second squared. That is the unit of acceleration, s over t squared. Energy, units t over s. 3.33 times 10 to the minus 11th seconds per centimeter, which in conventional units is actually 1.49 times 10 to the minus 3 ergs. Force, which is expressed in time over space to the second power. That is 7.32 times 10 to the minus 6 seconds per centimeter to the second power. And that is conventionally usually expressed in dynes, 3.27 times 10 to the second dynes. Pressure in Larson's system is expressed as T over s to the fourth power. And that is 3.52 times 10 to the fifth seconds per centimeter to the fourth power. And that's generally expressed in conventional units as dynes per square centimeter. 1.57 times 10 to the 13 dynes per square centimeter. And then momentum. Momentum is expressed in the reciprocal system as t to the second power over s to the second power. And that is momentum, and the natural unit is 1.11 times 10 to the minus 21 seconds squared over centimeters squared. And that's generally expressed in the conventional system as gram centimeters per second, 4.97, 4.98 times 10 to the minus 14 gram centimeters per second. And then inertial mass, t to the third power over s to the third power. We just went over that, but that's 3.71 times 10 to the minus 32nd seconds to the third power over centimeters to the third power, which is also expressed in conventional units as 1.66 times 10 to the minus 24 grams, which is the inverse of Avogadro's number. The values given in the first column of this tabulation are those derived by applying the natural units of space and time to the space-time expressions for each physical quantity. In the case of the quantities of the speed or velocity type, there are also the values applicable in the conventional systems of measurement. However, mass is regarded as an independent fundamental variable in the conventional systems, and a mass term is introduced into each of the quantities of the energy type. Momentum, for example, is not treated as t to the second power over s to the second power, but as the product of mass and velocity, which in space-time terms is t to the third power over s to the third power times s over t. The use of an arbitrary unit of mass then introduces a numerical factor. This, in order to arrive at the values of the natural units in terms of the CGS system of measurements, centimeter, gram, second system of measurement, each of the values given for the energy group in the first column of the tabulation must be divided by this factor, which is 2.236 times 10 to the minus 8. Okay, that's an interesting number there. It's very, very close to the square root of 5 times 10 to the minus 8. Okay, as we saw in Chapter 10, the masses of the atoms of matter can be expressed in terms of units of equivalent electric displacement. The minimum quantity of displacement is 1 atomic weight unit. It is therefore evident that this displacement unit is some kind of a natural unit of mass. In the first edition, it was identified as the natural unit of mass in general. The continuing theoretical development has revealed, however, that this atomic weight unit, the unit of inertial mass, is actually a composite that includes not only a unit of what we will now call primary mass, the basic mass quantity, but also a unit of secondary mass. The concept of secondary mass was introduced in the first edition without being developed very far. A considerably more detailed treatment is now available. The inward motion in space, which gives rise to the primary mass, does not take place from an initial level, occupying a fixed location in a stationary frame of reference. Instead, the initial level itself is in motion in the region inside unit space. Since mass is an expression of the inward motion that is effective in the context of a stationary reference system, the primary mass is modified by the mass equivalent of the motion of the initial level. while the previous deductions with respect to the essential features of the secondary mass component have been confirmed in the subsequent studies, a few of the details take on a somewhat different appearance when viewed in the light of the more complete information now available. The recent findings indicate that although the primary mass is a function of the net total effective positive rotational displacement, the movement of the initial level that is responsible for the existence of the secondary mass depends on the magnitudes of the displacements in the different dimensions separately. The scalar directions of the motions inside unit distance play an important part in determining these magnitudes. Outside unit distance, the scalar direction of the rotational motion is inward because it must oppose the outward motion of the natural reference system. However, as we saw in Chapter 10, the magnitude of that inward motion depends to some extent on whether the displacement in the electric dimension is positive or negative. Inside unit space, there is still more variability, as the motion in this region is in time, and there is no fixed relation between direction in time and direction in space. The rotational motion of which the material atom or particle is constructed is motion in space, but inside one spatial unit, the translational motion of the atom is in time. Okay, we're going to stop there. He kind of dove into this, and we'll have to kind of assess this concept of secondary mass tomorrow as we continue going through his book, Nothing But Motion. This is Dewey Larson on the Reciprocal System of Theory. Thanks for tuning in, and hope to see you tomorrow. Have a great day.